All right, all you cool cats and kittens out there, let's talk about graphs. Okay, so today we're going to understand important features and vocabulary of functions. Okay, so we have this inequality, 2 is less than or equal to x, which is less than 6. Basically what that means is the important information is from 2 to 6, but includes 2 and not includes 6. So another way we could write that is with a graph. We always graph from the smallest number to the largest number. Since 2 has the inequality next to 2 has a line, it's a closed dot. And since 6 does not have a line, it is an open dot. Now, this inequality says that x is bigger than 2, but it is also smaller than 6. So the area that is bigger than 2 and smaller than 6 lies here, which gives us the interval notation of bracket 2, 6, parentheses. Okay, so if we're talking about the next three, the first one, we can rewrite that if we wanted to use a number line. Then we would go from least 1 to greatest 7. Since the inequality by the 1 does not have a line, it is open. And then the inequality by the 7, it does have a line, it's closed. This also says that x is larger than 1, but at the same time smaller than 7. So again, it's that middle area here. Since 1 has an open dot, it's going to have a parenthesis. Then you put 1, comma, 7, bracket. Okay? So the parenthesis means that it does not include that number. It is not part of that line, but the bracket means, yes, this is an answer. And it's going to be the same thing with these guys too, but you're not going to have as much. So for this one, you could draw the inequality, and this one as well. It's going to be a lot simpler. Our important number here is 3. Since there's no line, it's open. On the second one, the important number is -2, and since there is a line, it's a closed dot. Now on the first inequality, since my x is bigger than 3, that goes to the right. And on the second inequality, since my x is not bigger than -2, that goes to the left. -2 is also the biggest for that one. Now for our interval notation, we always write from least to greatest. So on this, nothing is important until 3. So 3 is our first important number, that's what we write first. Since it is not included in our answer, it gets a parenthesis, comma. To the right forever and ever means positive infinity, and infinities always have parentheses. On C, to the left forever and ever means negative infinity. Infinities always have parentheses, comma. Our important number is -2, and since it is included in our answer, and we know it's included because it has a closed dot, it gets a bracket. So we're going to apply this idea that we've learned and talked about in Secondary 1 to graphs, which we haven't done before. So we're going to be specifically talking about the domain and the range. So the domain is the set of all of the first coordinates, usually the x. Okay, so the domain is written from the smallest to the largest or biggest value. It's our x numbers, so our left and our right. The domain is a set of all of the second coordinates, usually the y. And again, it is the smallest to the biggest. We always write in order from small to big. And then the range is going to be the up and down. Okay, so let's look at the picture. So these two graphs help understand what's going on in this picture. So we're trying to figure out the domain. So the domain is how far left and right the picture goes. So if I were to squish the domain and make it a flat line like this, my picture is going to the left forever and then to the right as far as we can go. So the domain of this graph is -infinity to infinity. It goes to the left and right forever, and infinities always have parentheses. Now for the range, it's as far as down as the graph is going to go, and then far as up as we can go. So the bottom of this graph, the furthest this graph goes down is here, and it actually touches -2 because it's part of the line. So you're going to use a bracket. So the range is bracket -2. That is the smallest it goes, as seen by this picture as well. So this is squished this way, up and down. So the furthest down it goes is -2, and the furthest up it goes is positive infinity, because it's going to keep going up forever. We know that because of the arrows. And infinities always have parentheses. Okay, so let's look at, let's go to these graphs. I would do these, but for video purposes, these aren't the best examples, so we're just going to skip over to graphs. So for this one, the domain, so how far left the picture goes, the furthest left the picture goes is -3, and it is actually touching -3, so that's a bracket, -3. And the furthest right this picture is going to go, well, it's going to go forever. So that's positive infinity, and infinities always have parentheses. The range, the furthest down this graph is going to go is here at -2, and it is again touching that, so we give it a bracket. And the furthest up this picture goes, well, it could literally go forever. So positive infinity and infinities have parentheses. For C, C is a parabola. So the furthest, the domain, domain is left and right, and range is up and down. So the furthest left this picture is going to go, see these parabolas are going to continue to grow forever and ever, left to right. And again, if we're thinking about squishing it into a line this way, I will end up having a straight line as a domain. So that means that my domain is going to be -infinity to infinity. Now the range, the furthest down this picture is going to go, it's not going to go past -3, and it's actually touching -3. So we're going to give it a bracket. And then this graph is going to go up forever and ever, so that is a positive infinity. Okay, let's move on to the next page. Okay, on the back side, we need to talk about intercepts. So intercepts is where your line crosses either the x or the y-axis. So the x-intercept is where it touches the x-axis, and the y-intercept is where the line or graph touches the y-axis. So, for example, on this, how you can tell them using a table of values is what it has here. So, if you would like to figure out what the y-intercept is, you plug 0 in for x and you get your y. If you would like to figure out what the x-intercept is, you're going to plug 0 in for y and you get your x-intercept. So that's what this is trying to tell you. Then the last step is to write the intercepts as an ordered pair. So for your x-intercept, that's going to be your number and then 0, and for your y-intercept, that will be 0 and then a number. Okay, so it's where it crosses on the axis. Sometimes you have more than one. It just kind of depends. So mathematically, for the intercepts of the function, so for this guy, what we would do is we would to make a table of values, x and y. So the first time I'm going to make x 0, and then what we're going to do is we're going to plug 0 in for x. So f of x, or your y, we can just say y, is equal to 2 times 0 minus 1. Well, that means that y equals 0 minus 1, which is -1. So the y-intercept is going to be at 0, -1. That's where our line is going to cross the y-axis. Now, in order to figure out what the x-intercept is, we're going to make y 0. And what that looks like is plugging in a y up at the front and then solving for x, which is 2x minus 1. So we would add 1 to each side. So now we have 1 equals 2x and divide by 2. So x is a half. So then your x-intercept is a half, 0. Okay, and then you could do the same thing on this one. We would plug in our 0 for x, and we would figure out our y-intercept, and we would plug in a 0 for y, and we'd get our x-intercept. That is how you can do it. A lot of the times, too, that we can just kind of look at the graph. Like, so for example, this graph. Oops, sorry, hold on. My goodness. Focus this. Okay, this graph right here, and you can use Desmos, but where this crosses here and here, those are our x-intercepts. And where this guy crosses up here, that's going to be our y-intercept. So if you use Desmos, you can figure those out super easy. You just like hover above and click on it, and then it will tell you. The other things you need to know is that this guy is also called a maximum. So there's two different types. There's relative and there's regular. And this guy's actually regular maximum. And I'll tell you the difference in a second. Oh, hold on. There we go. Okay, so when we have a parabola, when this is the highest peak possible, that's a maximum. When this guy is its lowest peak possible, it's a minimum. Okay. So this is the smallest y value. Now, sometimes we have relative ones. And a relative one would be like if our graph looked like this. Now, this graph goes forever up and down. However, it has these like hinge points right here and right here. These guys, this is a relative max and a relative min, which means that they're not the absolute. Like there is still information above or below, whereas these guys don't. This is like the toppest information and the belowest information, right? But this guy still extends on. That's why this is called a relative min and a relative max. Yeah. So let's look at this page right here. I'm just going to go over a few of these with you. Like I said, you can use Desmos to type these in, and I will show you that on another page or another video. Okay, so this guy right here, the domain, the farthest left and right that this picture is going to go is forever and ever. So this domain is going to be negative infinity to infinity. The range, the furthest down this picture is going to go is negative infinity, and the furthest up this picture is going to go is also infinity. It's going to continue forever and ever onwards in all directions. Now, 7 is a little different. This domain, the furthest left it's going to go is here, and that guy is at negative 2. Now it gets a bracket because we're actually touching it. It's going to go to the right forever and ever, so that's a positive infinity. Infinities always have parentheses. Now, the range. The furthest down this guy is going to go is here on this axis, which is 0. Again, it touches it, so we need a bracket. The furthest up it goes is also infinity, so parentheses. So you assume, even though there's not an arrow here, that it's going to continue to go, but here it doesn't go because it just stops. There is no other information about it. For problems like these word problems, I would highly recommend you create an equation and then plug it in to Desmos and you can kind of see what's going to happen. So like number 9, it says the bike charge will do an inspection for $5. So that's a flat fee. So y equals some flat fee. Flat fees don't have variables. Anytime you see the word per, there's a variable. So like this one. And plus sign charges $11 per. So anytime you see a per or a for or an each or an every, something that means I'm getting more than one item, that means that you need some sort of a variable. For repairs with a maximum charge of $60. So we cannot go above 60, okay? So I would graph this equation in Canvas, or in Desmo. No, in, Desmos. And then what I would do is I would look, okay, so can we really pay this guy? Can he pay us? No. So the smallest this thing is going to be is at a 0. And then the largest this guy is going to be at 60. So from 0 to 60 are the numbers that we're really focused on. That will give us a domain and a range. Okay, so I've already given you what the domain is. The domain, the furthest left we can go is $0, and the furthest right we can go is 60. Struggles. Okay, that is the domain. We can't have the guy paying us. That's not going to happen. So that's why we can't go negative numbers. And we can't go further than 60 because it says with a maximum charge of $60. And we are talking about money here. Like we're trying to figure out how how many hours, that was what this would be, how many hours to get this price, okay? And then the range would be the furthest down it's going to go. So 5 will be our furthest down, which you can double check. And then as far up as it's going to go, and you'll be able to see that on your graph. Okay, so now I'm going to show you what to do in a different video given your graphs, because I don't think I have one graphed for you. Nope. Yep. Okay, so now you get the idea. Okay, come back. See you. Bye.